If not, then we can begin with our today's session. Because this is very important. If we do not discuss this now, then later on it will be a problem for us, as we will be stuck with what kind of decision to take. So that's the reason why I told you about this first, so that we can take a decision collectively and then we can proceed with whatever is necessary. Yeah, guys, all clear? Any clarifications required? Anything that you need to ask? Anything that has not been delivered properly to you? Yes. If everything is clear, just mention like everything is clear. And if any doubts are there, please let me know what doubts you have. Okay, I think everything is clear. So we can move to our session. Okay, just let me see if recording is in progress. Yes, fine. So we'll begin with our today's session, right? So yesterday we had a good introduction to what kind of process AI follows, what kind of core concepts AI has, what are the core capabilities of AI, and then we slowly went into the data processing part, and then now we are at the ML, the machine learning part, which we will discuss in brief today, and I will make sure that you understand the entire concept properly. So this is like a pre-practical, enhancement that I'm trying to do, so that when we start with our, you will be familiar with these things and you will not have any doubts later on. Okay, so I hope everybody is fine with whatever I am doing. Okay, so I'll just share my screen. Just let me know if everything is visible. Yes. Is the screen visible? Yes. Okay. All right. So yesterday we looked at what exactly ML is all about, and we studied that we had two kinds of programming systems. One is your traditional programming system, and one is your machine learning system, which has two parts. Right? One is the algorithm part, and one is the model part. So algorithm takes your inputs and outputs and produces some kinds of rules, which of these rules will be fed as an input to the ML model, and we will get the output. Output is considered as the decision. So yesterday I gave you an example. So today, if I have to give another example, I can give the difference between apple and a banana, right? So you have the apple, you have a banana. Then you're going to try to tell the machine that okay, this is an apple, this is a banana, because you already have classified that, correct? So now you're just trying to train your machine to understand what an apple looks like, what a banana looks like. So you're going to give inputs and you're also going to give outputs and you're going to produce some rules. So these rules are going to be the inputs that will be fed inside your model, and the model will identify, okay, if I give apple, this apple should be predicted as an apple itself. It cannot be predicted as a banana. It cannot be said as a different food, right? So this is nothing but your machine learning model. Okay, so we also saw the difference between a machine learning algorithm and a machine learning model. The algorithm is nothing but a set of certain rules, certain steps that we have to follow in order to train a system, right? And a model is nothing but it takes these rules, it takes these defined rules, and it produces the output in the form of decisions, right? So model is responsible for making the decisions, and your inputs or the rules that are present, that is nothing but it allows you to follow certain steps or certain flow in order to predict that decision or make the decision, right? So then we came across the whole flow of machine learning system. So how does a machine learning system start with the whole data process? So first you have the data sources. Right? You have the online data sources. You can have proprietary data. You can have data from your local storage as well, right? So these are the different kinds of data sources that you can get the data from. Now, yesterday I asked a question to everybody, which everybody answered very well, which is what kind of what kind of in your mind when you say data. So a lot of people said structured, unstructured data, types of data, objects, right? All of these things will be in mind, and definitely we will have some kind of missing values or some kind of empty values, or empty in the sense like junk values, right? So these values need to be cleaned, need to be pre-processed, and that is why we are going through this step called as cleaning and pre-processing. So once we do the cleaning and pre-processing, then we start training the data. Now, while training the data, as I mentioned yesterday, we consider different types of combinations. Right? It's not about selecting a single type of training and saying that okay, this training is the one that I'm going to follow strictly. I'm not going to change anything. That is nothing but you are trying to limit the capabilities of your machine learning algorithm or your machine learning model. So what happens here is, as I told you yesterday, that we need to make sure we are experimenting with the data set that we have. So if you are not experimenting with the data set, if you are not saying that okay, I'm not going to just follow a strict rule, I'm just going to see which which split of data is going to give me an accurate result, which split of data is going to give me a better result. I'm going to go with that kind of split, so that in future when I again start training my model, I can try to experiment and see whether this concept, whether this rule that I adapted to is right or wrong. So that is where this whole concept of training data comes from. Now, once you start training the data, okay, there are a lot of different questions that come into picture. Okay, just like yesterday I told you, since everything is about experimentation, definitely if you're just focusing on the amount of data, it will not be much accurate, right? You need to also focus on the quality of data. So quantity is important and quality is also very important. Now, when I talk about quality, it's not about feeding like 1 MB or 2 MB, 3 MB. I'm not talking about the file size, or I'm not talking about the crisp quality of the data. I'm talking about the quality in the sense I'm talking about the features that go inside the training part. Okay, so this entire process that we call is nothing but a feature engineering. Now, feature engineering has different things. Okay, first thing that we have is trying to create new features from existing features. So, for example, uh, let's say you have a model, okay, and this model requires three things, okay, and you have the two features, right? Okay, let's say you are trying to predict how much is the sales going to increase in the fourth quarter, or maybe at the end of the year. Okay, you're trying to make an ML model which predicts how much sales is going to be done by the end of this year. Now, your first thing in mind, what will it be? That I have to get the sales data, I need to get the cost, I need to get the revenue, and how much has been spent on different things. Correct? Let's say your data has the cost, it has the revenue, it has the sales. Now, these three features alone might be enough. Okay, sometimes it might be enough to predict okay, how much sales a company has made. But here is one thing. Let's say the company wants to get the gross revenue. What will your approach? So this is a question. This is a question. So for getting simple sales data, obviously you can just create the aggregation of the sales data, and you can give the sales data to the algorithm and say that okay, this train this model based on these aggregations, and then it will give you an accuracy and will say that okay, this is the sales data at the end of the year. But now, what if you want to get the gross revenue? What if you want to get the gross revenue spent by the company? What is your approach? See, you have revenue, you have cost, you have sales. Okay, so sales is nothing but each month by month sales. So definitely, if you want to just calculate the gross sales, you're just going to add all the sales. I mean, the net sales, you're just going to add all the sales. Gross sales, obviously, it will be different. It will have some other features, right? External features. For example, how much did you spend on ads? How much did you spend on marketing? How much did you spend on campaigning? Right? All of these different features. So my question is, if you're making a model like this, what will your approach be when you talk about predicting what is the gross revenue of the company? Yes, please write it down in the chat box. What will your approach be? Just you can say it in simple words. I don't want like long explanation. Just give me a simple understanding of how you would you just rely on the sales data? Would you just rely on the cost data? Or would you just rely on the revenue data? Or would you do something which is apart from these features? You will also make a new feature and you will add that feature also while calculating the cost. The cross add extra features. Very good. So this is where the concept of feature engineering comes into picture. So since we already have some data, right? It's not like we don't have any data. We have all the data which we require. But sometimes what happens is, even though we have the basic necessity or the necessary data with us, we still need to have some extra amount of information in order to predict something, in order to make a strong decision. Now, when you talk about, let's give a very general example, like a generalized example. Okay, let's say you're moving abroad. Okay, let's say you're moving abroad with your family, or let's say you're just moving abroad on your own. You just want to study. Gautam, I'll come to that. I will come to that. Okay, I will definitely come to that. So yeah. So what I was saying is, let's say you came across a decision that you want to make. Your decision involves you moving abroad or your family moving abroad along with you. Okay. Now, the decision can be affected using certain factors. So, Gautam, listen to this carefully. Your answer is hidden in this itself. You will understand partly, and then complete understanding, I will answer you in detail later. So, here, your decision might be affected by certain factors. What are the factors? Money. How much money do I have to move abroad? Do I have enough amount of money? Do I have good financial backup for moving abroad? Okay, I have. Fine. Next, do you have the required knowledge? Do you have the required qualification? Yes, I have. Third thing, do you need any extra additional costs? If you need additional cost, you will see to it that okay, you might get some scholarship. If you see that okay, we have some scholarships available, fine, done. That's also right. Then there might be some external examination. Right? For example, if you go for masters, you need to write IELTS. If you go abroad, definitely you need to write IELTS because that will show your qualification of your English grade. Correct? And that is very important to move to abroad because usually they use English as a medium of communication. So now you have different factors that involve your decision making process. Now, similarly, in machine learning also, we have certain factors that will affect the decision making process of a machine learning model. So, in order to make sure that your decision is not 50% right, 50% wrong, you make sure that you have all the features ready in order to make that decision. Now, for example, taking coming back to your general example of moving abroad, let's say you don't have the financial coverage, but you have everything else. You have your grades, you have good grades, you have good reputation, you have all the, I mean, yeah, you have the external examination marks, or everything is good, but you don't have the financial coverage. Would you be able to move to abroad? Obviously not, because that one feature is going to affect your entire decision. So there is a chance that okay, you might get some sponsor. Okay, fine. If you get a sponsor, that is another case. That becomes a uh, separate case, right? It becomes like a exception case in general. So what I'm trying to say is that when you are training a model to make a decision, make sure that those decisions that are being made by the model need to have the factors prior to the decision. So any decision the ML model makes is not based on what the ML model understands. Okay, it's on us. It's on us users how much data we give to the ML model to train it in order to make it perfect and make it understand what decision to make. So coming to your question, Gautam, will adding additional features result in better accuracy? Adding additional features sometimes results in a better accuracy. Sometimes it is resulting in the right decision making. I hope that answers the question. If not, you can ask me a counter question to that. Yeah, okay, fine. Thank you. Yes. So it's not always that when you add additional features, you will result in a better accuracy, but sometimes adding additional features will give you the necessary decision that you need, right? Just like how I gave the example of moving abroad. So if you don't have the financial status, okay, but you have everything else, so there is still a chance, there is still a very less chance that you cannot move abroad. So what will be your decision? Okay, maybe I want to move abroad because I don't have a financial status right now. Correct? So your decision making process will be affected. But what if you have everything, right? You will have the decision ready saying that yes, I can move abroad. So I hope that process of feature engineering, what we think is important, is clear. So this is the reason why featureization or feature engineering is very important when it comes to machine learning. Now, coming to your final step of the learning process and feeding the input data and making the predictions, right? Now, just like I gave you the example of moving up, okay, that is a very general example. Now, let's take a scenario where we have three people. Okay, let's take three different people. One person has a good financial condition, they have good marks, they have good grades and everything, but they have a criminal record in the country. Okay, that is one thing. That is one person's feature. Second person has the feature that they are passing all the qualifications. They have financial condition, they have good reputation, they have good grades, they have good qualifications, everything. Okay. Third kind of person does not have a good financial condition and does not have good grades, but everything else is there. Reputation and qualification, entrance examination, everything is there. Now, if my model has been trained on all those four features, what are my four features here? The first feature is financial condition. Second feature is my reputation. Third feature is my grades, and fourth feature is my external, external feature, which is nothing but entrance examination or some kind of additional cost that you have to pay. Right? These are my four features that I need to cover. Now, if my model has not trained on these four features, do you think a person with not having the two features, okay, the two other features, will have a better decision making process or will have a worse decision making process? Obviously, if I train with less number of features which are not involved in the data set, definitely my decision process is going to be affected. So even if the person, let's say I trained my model only on financial condition and grades. Okay. So let's say a person having financial condition and good reputation is present, right? And let's say their grades are not good. What will happen? Definitely the decision process will be affected, right? So the decision is always, you would say, proportional to the quality of data that you have, to the quality or I would say the amount of features that you are trying to train in your ML. So I hope everybody understood why it is necessary to have this feature engineering process and why particularly the input data also needs to have those same features which we have trained the model. Okay, I hope it is. If you guys have any doubts, please ask. Everything clear? Yes, yes, no. If there are no questions, then I'm assuming that okay, everything is all clear. Yes, okay, fine. Thank you. All right. So now coming to the workflow of machine learning. Okay, so we will see the entire workflow of machine learning first. We have already seen in some kind of high level architecture, we have seen what is the entire steps that are required for machine learning, creating a machine learning workflow. But we will just have a technical discussion on what kind of workflow should an ML system or an ML pipeline follow. Okay, so this entire thing is very much necessary because this will lead you to a better uh, path. It will give you a clear idea about how this entire ML thing should work, how this entire ML model should be built, how this entire workflow of machine learning should be. So first thing is, yeah, before moving on to the types of ML, we will first understand the whole workflow of ML so that we can slowly go on to the types and then we will start with the in-depth discussion about the types of machine learning. Okay. So when we talk about the workflow of machine learning, the first thing that comes into mind, it should always come into mind, is nothing but what exactly your strategy is. If you don't have a good strategy, okay, for example, you are trying to, again, coming to the same example of predicting whether an apple and a banana is different, right? What is the first thing that will come to your mind when your goal is that? You need to have a goal, correct? You need to have an objective. So that strategy, in other words, is nothing but your objective. So you need to have a good objective, whether or not I have to do this task or I have to do this task. So let's say your task that people have, maybe somebody has given you a task that you have to identify or you have to differentiate between an apple and a banana. Now, what is the first thing that will come into your mind? You will say that, okay, apple and banana. So I cannot differentiate between a banana and orange. No, that is not my goal. Right? So my strategy has to be fixed according to the use case that I'm going to get. So if I give you a problem statement and that problem statement is something related to a topic and you say that okay, I don't understand this, so I will just assume my own strategy and I will do it. So will the output or will the final decision be similar to what I am expecting as a guide? Obviously not, right? Because my problem statement that I gave you is different from what you have actually implemented. So, so you might be right for your problem statement, but you are not right for the problem statement that I gave you, correct? So it is always important to have a strategy in mind, what you are going to exactly follow, what you are going to do. So strategy involves different things. First thing it involves is the decision that you have to make. What is the decision? The output, right? The prediction or the classification of whatever you're trying to do basically with your system. Second thing is you need to understand what is the data I am working with. Since this is all about machine learning and all about AI, everything works on data. AI especially and machine learning, everything works on data, correct? So you need to have a perfect decision in mind what data I am working with. I mean, decision in the sense, not the output decision. The decision is related to what kind of data you're working with. For example, if I picture an apple, what is the first thing that comes to my mind? Shiny surface, red color, right? A leaf, correct? Edible, right? So these are some features that come in mind. Even shape, correct? It's a round shape. So these are some characteristics of an apple that I can visualize in my mind, right? What about banana? Banana, you will visualize. Okay, it is long, it is yellow, it has a yellow covering, it has a white flesh, right? White fruit. So these are the characteristics of the data that you will define. That also comes under your strategy. Okay, this is done. Now coming to data collection. Now strategy is done. Now you know what data you're working with, what kind of data it is, what your end goal is, what your objective is, what your idea is, what your problem statement is, right? Done. Now coming to data collection. So in data collection, what are you going to do? You are going to collect the sources of different types of data that you have. So now every time an apple cannot be the perfect round shape and red color, right? Sometimes the apple can also be green. What in that case? You cannot just say that, okay, since it is green, it's not an apple. No, it can be an apple, right? What if the color of the apple is pink? Maybe it's a light shade of pink. What if that's the case? So you will have different variations of the data, right, when you're collecting the data. So it is very important that when you're collecting data, you need to focus on the variations of different types of data. So now you might think that, okay, sir, this is quite easy to understand, isn't it? But trust me, guys, this is the place where people actually make mistakes. You know why is that? Because the data collection part is considered as the most important part in your machine learning. Not even your algorithm is considered as important. You know why is not algorithm considered as important? Because algorithm works on what? It works on the data, correct? So if you don't have the right amount of data, then how is your algorithm going to work? So algorithm has got nothing to do with your machine learning prediction. I mean, obviously it has some effect, definitely. I'm not saying it does not at all, but the most relevant part of machine learning is your data collection part. So in order to make sure that your data collection is good, you have to make sure that you have various sources of data so that you will not make any mistake in your decision that you have to do. Right? So there can be different things that are there. Then after data collection, right? In data collection, yes, Philippa, in data collection itself, you have the features of the output. Definitely. Then comes the data pre-processing part. So as I told you that data collection cannot be always accurate. Sometimes if you're collecting the images of Apple, maybe in some website there is a photo of an orange in between. I mean, that doesn't make sense, correct? So if you're training an apple and a banana image, you should have an apple image and a banana. You cannot have any other images while training the data. So since you got an orange image, what are you going to do? You are going to detect that part of the data and you are going to delete it from the data. Why are you going to delete it? Because I am not here to predict an orange, an apple, and banana. I'm here to predict only an apple from a banana. Correct? So that is the reason why we need to do this data pre-processing part, wherein we will remove the features or maybe the parts of the features that is not required by the machine learning. Okay, so that is the process of data pre-processing. Then coming to your next process, which is nothing but data modeling. Now, this data modeling process is slightly trickier, actually. Okay, in data modeling, there are various different things. Does anybody have any idea about data modeling? Just to just to be aware of whether you guys know what it is. No? Okay, Sunita says no. Fine. What about others? I will explain it definitely, but I'm just here to just get an idea of what exactly do you understand by data modeling. Okay, I assume people don't know about data modeling, so no worries. So we'll discuss about it. Okay. So while discussing, I'll just make notes over here so that later on you can refer it. So in data modeling, you have three main stages. Okay, so here the entire thing becomes very big. So till data pre-processing, it's like okay, it is important, it is easy to do. You just have to focus on the data quality and everything, right? But data modeling is where things get a little trickier. So we have three main stages of data modeling. It's blueprint for data, right? Um, you could call it as a blueprint, but it is more than just a blueprint. I'll explain that. Clear. Okay. Gautam says to understand patterns and relationships. Yes, yes, that is a good way to say that. And yeah, there is more to it even than just identifying the patterns and relationships. Okay, so we will come to that. So first thing, the first stage of data modeling is nothing but a conceptual. Okay, so this is related to the question what. It's like a what question. Okay, what means? I'll tell you what this what means. Okay, it's like you are creating a high level view. Okay, you're creating a high level view which identifies the main things you want to track. For example, in an apple, what will you track about? You will track about the shape, right? You will track about, I'll just write it down here, high level view, okay? And here you're going to track the main things or identify the main things that you want to track, correct? What will you do? You will do shape, color, size, um, external features, right? All of these things you will consider. And you will try to create a relation between the shape, color, size, external features of an. So just like Gautam said, understanding the patterns and relationships, that is the first stage of your data modeling. So that is your conceptual model. Okay, so I'll just write it down here and identifying the relation between these uh, things or features. Okay. So this is your first. Then coming to your second thing, which is nothing but creating a logical. Now, what is this logical model? The logical model is related to the questions of how. So, how are you going to, how are you going to find specific information? How are you going to uh, add to this decision? How are you going to make this decision? That is nothing but your logic. So this model, this part of the model adds more detail. It specifically gives uh, what kind of information, kind of specific information we need. Okay, so this is nothing but your logical model. So for example, if you are trying to let's take a different example. Yeah, let's take an example of a loan processing system, a loan approval system. Okay, ML model to predict whether a person gets a loan or not. So here, what will you do? You will add some details. For example, the name of the person. That will be a detail, right? That will be a logical detail. Second thing is what the person does. What is the not the characteristic of the person? What is the job that the person does? What is the income that the person gets? Right? What are the different backgrounds that the person has come from? So these are nothing but related to your logical model. So you're creating a logical model within your entire data set. Then comes the final stage, which is nothing but your physical model. So in physical model, we usually consider this as the build stage. Now, why is it called as a build stage? It is because this is the actual design stage. Okay, actual design. What does this actual design do? This tells the this tells the computer exactly how to store the data in a specific database system. Right? For example, if you want to store data somewhere, you will choose a physical model. Right? What will you choose? You will choose maybe an Excel file, maybe CSV file, maybe an MySQL server, maybe an SQL database, maybe a NoSQL database. It is totally up to the user what they want to. So these are the three main stages. Now your question might be, okay, this is fine, I understood this, but why do we actually do this? Why is data modeling very necessary? It is considered as a very necessary process. So without a data model, right, your data becomes like a junk. It becomes junk. Why is that? Because you know that the information is there. You know that information is present everywhere, correct? But it's impossible to find, okay, the data that you require or use the data that you require efficiently. Now, what does this mean? Data modeling basically ensures three things. Okay, it ensures first thing is consistency. Okay, how? So everyone agrees on what a person's username means, what a person's background status means, right? So this is nothing but related to your consistency. Considering the example of your loan approval system. Okay, so here it's like everyone agrees on what the data is about. Correct? So data modeling ensures that there is consistency involved in the data. So this is your first feature. Second thing, what it ensures is efficiency. Okay, why does it say that it is very efficient? Because if the data that you're storing is not going to run properly, I mean the data that you have is not going to be organized properly, then how are you going to have a output or a decision which is going to be faster, correct? Efficiency means that data modeling gives you a faster approach of storing the data as well as running the data. So it's basically nothing but the database runs faster because of the organization of data. So since we are doing this entire conceptual model and entire logical model, it is going to give us the ability to store the data or organize the data inside our physical model, which is our database. Right? So the database will obviously run faster if the data is organized properly. Right? What if the data is unorganized? What if it is disorganized? Definitely you're not able to run things faster. So considering a real life example itself, right? To make things very simple, consider your workspace. Let's say you are a student or working or anything. You are in your workspace and you see that okay, your charger is here, your laptop charger is here, your laptop is here, your book is here, your diary is here. Okay, everything is just messed up. Now when you see all of this mess, you feel like, oh, I want to clear this out and then work. Correct? So what will happen? You will first clear everything. Once you clear everything, it becomes very faster for you to, you know, focus on your work. So you become highly efficient. But what happens when you have all of this mess? You will try to clear this mess. You will be like, okay, I'll procrastinate. I will do it later. I will clear this mess later. I will not do it now. But it's still in your mind. It's distracting you. That, oh, I have to clean this mess later. But here you lose your efficiency of doing it. So similarly in ML also, since we have this data modeling stage, it helps us to make the entire process very efficient. Okay. Then coming to your accuracy part, wherein accuracy as in it prevents a lot of mistakes. How does it prevent? Because it is going to create a logical model and it is going to create a relationship between the features that you are going to get from the data set. So once you get the features from the data set, then definitely you will feel that okay, I know that the data is interconnected with each other. This means that my data, whatever I've collected, has a strong relationship, has a strong pattern across the entire data, and I have a good relationship between the different types of features within my data set. So this will obviously increase your accuracy and it will prevent mistakes. So it prevents mistakes. Yeah. For example, again, as I told you, if you don't create a data model, you will just have unorganized data, and this unorganized data will basically like mess up with your entire decision, and it might make a mistake. For example, predicting apple for banana, or predicting banana for apple. That can be a big mistake if you don't focus on the data set that you have, or if you don't work on a data model. So I hope it is clear what data modeling. Yes, is it clear, guys? What data modeling is? What are the three stages? What is the insurity it gives us? Yes. Thank you. Okay. So this is about your data modeling. Now comes the process of your training and evaluation. Now, when it comes to training and evaluation, right, there are different things that you can come across. Okay. So by training and evaluation, what is the first thing that comes into your mind? Yes. What is the first thing that comes into your mind? Okay, Nitesh is splitting the data. Fine. What about others? Okay, we'll take splitting data first. All right. So when it comes to training and evaluation, first part is your training and then you evaluate. Right? Obviously, you will give the test first and then your marks will be evaluated. You cannot evaluate the marks before giving the test. Correct? So the first stage is your training stage. Now in the training stage, what happens is we have the data ready, we have the data model ready, we have the database ready. Everything is ready with us, everything is organized properly, and now we have a clear picture of what our data looks like. Now, what you will do is during training, okay, this training phase is going to see where the model is going to find the patterns and it is going to learn the rules of the task. Now, if you consider your scenario where you're predicting between an apple and a banana, what is your task? Your task is to predict two different fruits, correct? So the training part should build a rule which says that okay, we are trying to detect or we are trying to predict a fruit from a different apple and banana in specific. So these are nothing but your rules for the task. Okay, so now you have the data patterns, you have the rules. Now you have two things. What are you going to do with these two things? These two things are nothing but present inside your data set. Correct? Whatever data set you have built, everything is present inside that. Right? There is nothing that is coming from external sources. Everything is coming from the first four processes that you have done. Okay. After that, in the training part, the first thing is your input. Okay, in the training part, the first thing is your input. So during selection of the input, you are going to come up with a strategy of how much data should I give for input and how much data should I give for output. What does that mean? As like just like Nitish said, it is about splitting the data. So you split the data into two sets, okay, or two or more sets. So we will come to that later on. But right now we'll just focus on what we do in training. So we split the data and we will take one part of the data which is called as the training data. Okay. Since we are training the model, we are going to take that one part of the data called as training data. Okay. Now, what will this training data do? This training data, okay, has the data where the answers are already known by the user or the model. Okay, so the answers are already there. So in my training data, I will have certain set of apple pictures, I will have certain set of banana pictures, and I will tell the model that, hey, recognize this. This is the banana, this is the apple. So whenever you see some image which is external, which is never seen before, you already know what an apple is, what a banana is. I have already set the rules, correct? So I have already set the rules. So based on those rules, you have to train yourself and you have to identify if I give an external source of data, it should predict whether this is an apple, whether this is a banana, or if it is neither of them, it is going to just predict error or maybe none or not a fruit or maybe nothing detected. Correct? So this is nothing but your training part. So the main goal of your training part is to minimize the loss. Okay, now we will come to training accuracy, loss, prediction accuracy, validation loss. All of this we will come to it later on. But first we will understand the entire basic structure of how things work. Then we will slowly get into all of this. Okay. So our main goal in training step is to minimize the loss. So what are we doing here? The gap between the model's prediction and the actual reality is nothing but the loss. For those students who never understood what loss actually means, loss is nothing but the gap created between the model's prediction and the actual reality. The model's prediction and the actual reality. What is the model's prediction? Based on what data you have given. What is the actual reality? The originality of the decision that you have taken. Okay, for example, let's say I am a robot. I am a robot. You guys are all, yes, obviously humans. You know better than me because you have created, and you have created the robot. Now, for a robot to understand, okay, this is a pen, this is a book. What will you do first? You will try to understand first, right, whether this is a book or this is a pen. And obviously, you know that as well, correct? So you know that this is a pen, this is a book. So that is nothing but your actual reality. Now, when you give these images to the robot, to me, I need to first understand what is a book, what is a pen. Sometimes there might be some scenarios where I might lose my thought and I would give a wrong prediction saying that instead of a pen, I'm going to say this is a notebook. I know that's not possible. I'm just giving a scenario. Okay. So if I say that it is a notebook instead of a pen, you know that it is a pen, right? You know that it is a pen. But I am saying that it is a notebook. So the difference between your answer and my answer is nothing but the loss. Correct? So in ML, same way, the loss is nothing but the gap between the model's prediction and the actual reality. Okay, this is your training process. Then coming to your evaluation, which is nothing but like your you know, calculating your final grades or calculating your final subject, right? So here, once the model has finished studying it, once the model has said that okay, this is a book, this is a pen, I know now what is a pen and a model. Now I will actually do the evaluation part. Now I will give the robot, I will give the ML an object and say that okay, this is the object. I will not say what it is. I will not say it is a pen or a notebook. You have to identify whether it is a pen or a notebook. Let's say the model identifies correctly that it is a pen. So you have successfully trained the model to understand what a pen is, what a notebook is. Okay, so this is nothing but an evaluation. So in the evaluation part, we use something called as a test data. So in training, what did we use? We use training data. In evaluation, what were you using? We are using the test data. In test data, we have the data set or the data which the model has never seen it before. Okay, it does not have that data in the data set ever. It has never seen that image before. It only has the previous knowledge what you have given to the ML model. Based on that model, it is going to make the prediction whether this object is belonging to this category or this category. So this is nothing but your evaluation. Okay, so the in this evaluation process, we will just ask the model to predict the outcome for the new data that we are feeding. Right? Without telling the data, without telling the model that okay, this is the pen. No, we are not telling anything because this is your exam and you have to identify and you have to get to it. So then we will compare whether the prediction is same as the actual reality. So the main goal in evaluation phase is to see how well the model generalizes in real time. So how generally the model gives a good output is what we are trying to focus on. Understood what your training and evaluation is? Simple, right? Very simple. And measure performance. Yes, Solika, very good. That is exactly what we mean by evaluation. Then coming to optimization. So now here things again, as I told you, things will become messier later on. But now since we are just having an overview, I want to make sure that it is clear now so that later on, whatever we do, we don't have any doubts, we don't have any messy parts that we have to focus on. So all the mess will be cleared here that later on we smoothly transition into whatever we are trying to look at. Okay. So here we have our optimization process. So what is there in the optimization process? Basically, in the optimization process, we are trying to optimize, we are trying to improve the performance. If the model is not able to give the correct answer based on the input data, we will just try to increase the data. We will try to maybe pre-process the data and say that whether the data is correctly processed or not. Right? That is nothing but your optimization. Very simple. So we will come to optimization in detail in the later session once we finish with the training and evaluation part. Okay. Then comes the deployment part. So deployment part is where your ML model comes into real life. So till now, whatever you're doing is inside your system. It's inside your PC. It's inside your local system. It's inside your VS Code or your coding environment. Once you get out of that is where you try to deploy the model. So deployment is the process of launching this ML model as a proper system or as a proper workflow which can be integrated with variety of systems. For example, your front end, for your website, your mobile application, right, etc. Then comes your performance monitoring. So in performance monitoring is more about data analytics. It's about visualization. It's about visualization of how well the model has performed. So if I say that my model has performed well on training data and not well on testing data, I will compare both the results by using some kind of visualization. What visualization would I use? Maybe a bar chart, maybe a pie chart, maybe a stacked bar chart, maybe a column chart, right? This is nothing but your performance. Now you might see that there is a flow between optimization, deployment, performance monitoring, and optimization. So why is this circle? Why is this cycle over here? So what does this say is that if you are optimizing the model, you are launching the model for deployment. After the deployment, you're checking the performance regularly. You are just keeping on monitoring the performance based on your accuracy that has been set. So let's say one day you saw that the performance is degrading. Okay, now you're panicking. Right? Okay, my performance is starting to degrade. I have to do something about it. What will you do? You will see the results of those performance monitoring system. You will send those results back to the optimization process, and you will optimize the model based on the results from the monitoring process. Inside the monitoring process, we have to be so smart that we monitor which part of the ML model is trying to give us the wrong uh, prediction or wrong decision. So once you identify which part of the model is giving a wrong decision, you will feed that into your optimization model. Optimization process will optimize everything and will give you a better performance. Once you get a better performance, again you will deploy, again you will monitor, and you will keep doing this. But what if you find out that performance is just degrading every single time that you deploy and you're monitoring, and it's not working? You have maybe optimized the model 5 times, 6 times, but you're just seeing very small difference between the accuracy and the performance. So now you might understand that okay, the problem is not in the deployment process, the problem is inside the third stage, which is our data reprocessing stage. Now you will again start from the beginning. Okay, so you don't have to train the model again. You just have to make sure that you have saved the model. After saving the model, you will just input the same data flow inside it, and then you will go with the final evaluation. So this is your entire workflow of machine learning. This is entirely what we will discuss in our machine learning practical or industrial sessions. I hope this entire workflow of machine learning is well and then coming to the final part where your machine learning engineering lies. Now this topic guys is not exactly your entire syllabus, but it is very important if you are considering to have a good career in machine learning. So before we move on to this, it will take maybe 5 to 10 minutes to explain all of this. But before getting into this topic, did you understand what the entire workflow of machine learning is? What is the entire workflow of machine learning consisting of? Yes or any doubts? Okay. Any doubts, guys? Any doubts regarding the workflow of machine learning? Okay, fine. All right, guys. Uh, that's about my workflow of machine learning. Then we will proceed with machine learning. Okay. So this is something that is outside your bookish knowledge. This is something outside your bookish knowledge. So make sure that you try to understand as much as possible, because I know that in the first look, first glance, you will see what is this entire thing. It's confusing me. I'll just zoom in so that you guys can have a better look at it. Just let me know if the entire thing is visible. Is it visible, guys? Is it like is it tough to see it? Should I zoom it more or is it fine? Yes, yes, visible. Okay, fine. All right, all right. Thank you, thank you. Yes. So coming to this illustration, okay, so this is more about the entire, your career path that you choose. So I know a lot of people have chosen ML because you want to have a good career in ML since it has a good prospect and it has a good scope also, right? So now, if you need a career in machine learning, you need to understand the whole process of machine learning engineering. Because if you are planning to become a machine learning engineer, which you should do, because if you're not planning to become an engineer, then the entire hard work that you're doing is just a waste, correct? So your main focus is to become a machine learning engineer. So to become a machine learning engineer, you need to have a good idea about this entire flow of what exactly a machine learning engineer does. Okay, first thing, first and foremost is your data pipeline. The first thing when it comes to your machine learning engineer role, first thing you need to understand is you need to have a data pipeline. Now, your question might be, what is a data pipeline? Data pipeline is nothing but just the same thing that I explained you in your machine learning flow. What is it? So before we build the model, we need the data to be of high quality. And data we can get from different sources, correct? So from different sources, we accumulate the data and we try to validate the data and explore the data. So how are you exploring the data? By doing some kind of exploration, by doing some kind of data analysis, right? So to become a good machine learning engineer, you need to have a good idea about exploratory data analysis and validation of data. So the first part of our practical session will begin from exploratory data analysis and cleaning data and all of that, pre-processing data. Then we will slowly move on to how to start, defining the model, how to start training the model, then evaluating the model, and then finally optimizing the model and deploying. Correct? So the first part is where you will try to accumulate the data, explore the data, validate the data, and then start cleaning the data based on what your exploration. So your source could be anything. Your source of data could be from cloud, from databases, from documents. I already explained this, so I don't have to go into depth. Correct? Then coming to your wrangling. So now what is wrangling mean? It means nothing but in other words cleaning. So we check for errors in the data. Maybe there is some kind of error that is there in the data set, some kind of junk value, some kind of error missing value. You will try to clean those data. Maybe there is some kind of duplicate value, right? Maybe some values have appeared 1,000 times. So obviously I don't want duplicate data. So I will clear those duplicates. This is nothing but your wrangling part. Okay. Then coming to your hub. What is your hub? The hub is where you store the clean data which is designed by the user. So after doing exploration, after doing validation, after cleaning the data, after processing the data, after removing duplicates, after removing all the missing values, you will then come to the part where you have the clean data ready. So this clean data is where you will split the data into train and test. Okay. Once you split the data into the train and test, here is where your machine learning pipeline comes into. Okay, what is the first step? Data pipeline. What is the second step? The machine learning pipeline. The machine learning pipeline is nothing but where your learning stage happens. Okay, so in the learning stage, since you have training and testing data sets, you have two different data sets. The learning happens in the training part. Okay, so when it comes to model engineering, okay, you can see here we have model engineering. So in model engineering, we use the training data to learn or experiment that okay, based on these data sets that I have, based on this training data that I have, I'm going to experiment with different algorithms. Okay, I'm going to experiment with different algorithms. I'm going to see different parameters. I'm going to see different types of code, and then I'm going to engineer the model. I'm going to create a model out of it. Once I've experimented, I will get to know okay, which is the model that I should use for this particular scenario, and that model you will take into consideration. Now, when you take this model into consideration, you're not just training the model, but you're also doing two different things. You're doing feature engineering and you're doing hyperparameter. Okay, so in feature engineering, you try to create new features. Already explained that, so we'll not get into it. In hyperparameter tuning, you are going to create one such parameter externally, which is going to define or optimize the performance of your model. Okay, so we will come into that in detail. Right now, I'm just giving you a high level overview of what machine learning engineering is all about. Okay, once you have done that, it's all about evaluating the model, then finding out that okay, the evaluation is not proper, so you will pass the parameters to model. Again, you will train the model. Again, you will test the model. You will keep doing that until you get a good accuracy, good evaluation model, right? Once you're happy that okay, my evaluation is done, and I've got a good accuracy which I'm supposed to get using my test data set. I'm happy to start packaging the model. What is the packaging of the model? Model packaging is the process where we are wrapping the model into a standard format. Now, what is the standard format? It is called as model versioning. So you will create a file such as .pkf or .jar or .h5. Right? These are different formats, file formats where a model can be stored. So you will store that model, you will save that model, right? And then you will start packaging the model in the form of a Docker or a Kubernetes system or a Docker container, right? Or a service, a microservice, right? So there are three types of serving that you can do using model serving, which is creating a microservice or general service, creating a Docker container, and creating Kubernetes cups. Okay, then you start build and integration testing. So this is where your software pipeline starts coming to picture. So your software code pipeline is the place where you start treating the entire pipeline like a professional software. Now, what do you mean by a software? Anything that can perform certain set of operations or certain set of calculations or any kind of operations that is required by a certain use case. So let's say you have built a machine learning model for, again, the same example, loan approval system, right? Now, this machine learning model on its own is just a model, right? It's nothing that you can use in your actual day-to-day life. Not everybody would, be able to run a machine learning model in the system. What about the people who want to use the software but not with the technicality? They just want to use the software because they want to approve the loans of the people. Who are these kind of people? people like the people who are involved in non-IT related roles. For example, your banking professionals, your banking employees. Now, banking employees will give loan based on some kind of system, right? So that system is nothing but a software. Now, that software which the user or the employee sees, okay, that software is for them to use. But the internal working is nothing but your data pipeline, your machine learning pipeline, or whatever technology you have used. It is all of that, which is the internal working of your software. So always remember that software is nothing but a combination of a data pipeline and the other technologies that you're using. It could be machine learning, it could be deep learning, it could be generative AI, it could be anything. Okay. So software is the part where we will start building the model and we will start testing the model. So testing is where your banking employees will be like, okay, fine, I'm going to test this model. So you will give it to various different people. You will say that please start testing the model so that we can check whether the performance of a model is good or not. Right? So you will do all of the testing and you will realize that performance is very good. If the performance is good, what will you do? You will start deploying the model. Deploying means you will send this model into production. Whatever you were doing till now is nothing but development. The final part where you're deploying the model is nothing but production. So this is the difference between development and production. In development, you are just doing the initial process. You're doing the entire processing part. You're doing entire um, pre-production part, where you're testing the model, where you're evaluating the model, where you're packaging the model, you're building the model, you're testing the model, right? You're integrating the databases and all of that. In the production, you're not doing anything. In the production, once everything is finalized, you are producing this model into the market. So in the market, you are going to sell this software saying that I have built this software. This is for the people to use and the people will pay money or whatever. If it is free, they'll use it for free. If it is paid, you will give some charges that they can use. That is where your model will go into production. And in the production, you are going to do your monitoring of the performance and your logging. So just in case in production you find out that people are not really satisfied with your model, maybe there's some kind of problems, maybe there's some kind of problem in the performance. What will you do? You will take the feedback from the model performance and you will send it back to the starting process, which is your data. Then you will follow the same process until the build and testing is done. Then you will again deploy the model and then again the processing. So it is nothing but a cycle of continuous integration, continuous development. Okay. So this is your entire machine learning engineering in one single. So obviously we will start from exploration, validation, data cleaning, data collection, data splitting of data, organizing data, splitting of data, model engineering, model evaluation, feature engineering, hyperparameter tuning, model selection, performance metrics, accuracy and precision, recall, packaging the model, then creating a model version, so doing model versioning, right? We will also do that. Then model serving, we will try to create a Docker container for that. Then we will try to build and test integration testing. Then we will produce or we will just deploy the model into production. So this is the entire pipeline that we are going to study in our 60 hours of session completely from scratch. And this will give you a very good idea about how you have to proceed in this machine learning engineering career. So I hope all of this is clear and I hope this was informative for you so that you have an idea now that okay what an actual machine learning engineer does. So I hope everything is clear. We'll stop the session here today. Tomorrow we will start learning about different types of machine learning techniques. Then slowly we will progress into the practical session and then we will see one by one each